Sai Pranav also got infinity. Yeah. Okay. All right. What about Ahan? Yeah, I think infinity is the right answer, because how did you get to infinity? You just drew some this one, huh?
So I visualized it.
Visualize it. Okay, Madhura is also joining. Hey, hi Madhura. Okay, we are doing question number 16. Shreyas is also joining. Good. So a rectangle needs to be cut into two parts of equal area by a straight line. How many straight lines are possible?
Hello, sir.
Sorry?
Hello, sorry I joined a bit late.
No problem. We are just starting and we are looking at question number 16.
Okay, sir.
Shreyas, please read it. A rectangle needs to be cut into two parts of equal area by a straight line. How many such lines you can draw?
Sir, can you repeat the question?
Sorry? So rectangle is something like this, right? Right. Now you have to cut it into two parts by a straight line, and how many ways you can, how many different straight lines can you draw? Right? How did you visualize it, Sai Pranav?
So I just visualize lines in my head along the rectangle.
So maybe you can cut it like this. This is one way.
So and then you can like just turn the line, like if you take the line at the center point of the rectangle, then you can turn it 1 degree by 1 degree by 1 degree.
Yes,
and then like that, this still remains same.
So if you see the rectangle, it is symmetrical in two dimensions, right? If you go to the right and left, it is symmetrical, and if you go to the up and down, it is also symmetrical. So it is symmetrical on two sides, and hence it has got a clear center point. Okay, now it happens that if you let us take format. So this, if this is the center point, right? Then any line that passes through this, okay, you will find that it what do you call, it cuts the rectangle into two equal parts. It need not only be diagonals, or it need not always be the straight lines like this, okay, or like this, but even some line like this which goes through this and cuts like this, okay, so, some angle, but it is passing through the center. You will find that the two sides are equal, not only in area, but they are equal in shape also, you will find. Okay, so this you have to visualize it only. There is no other thing. But if so, and this is typically true of any shape which has got a clear center and a symmetry. Okay, so center is difficult. So if you put some odd shape like this, now this will also have some center. Okay, but it will not be possible that any line that you draw through this will cut into equal parts. It will not be. But what is important is symmetry. Now, if you see here, the rectangle, it is like, it is having a shape which is symmetrical. So if you put a line through this, you will find that it is the two parts on this side and that side are exactly equal. And that is true even for any way you bend the line. Anyway, however degrees you bend the line, as long as it is passing through the center, the one piece on one side is exactly equal to the other side. And that is what it means by symmetry in two dimensions. Okay, which will not be the case for the odd shape that I have drawn. Okay, so if this shape is there, and let me take a format, and if you just draw some line through the center, okay, I mean, imagine this is going through the center. Now one side of the piece will be very different from the other side of the piece. They are not equal, neither in area nor in shape. Okay, now there are different kinds of shapes, but rectangle is one such symmetrical shape, and hence you can do this. You could see this everything, right? I had shared the whiteboard. You could see this, right? Everyone?
Yes, sir.
Okay. Okay. Then I will stop sharing and I will go back to sharing the screen. So question number 16 is this. Okay. So let us try to finish this. Consider the sequence of all natural number 17, which do not have a digit 3 in strictly increasing order. I think this we had seen it, I think, right? What is the 300th number? Actually, there is no formula for this. Okay, you have to just count it, but you have to count it smartly so you can count very quickly, because you know that every in all the, like, if you start from 1 to 100, okay, then 3, 13, 23, like this, there will 43, 53, etc. All the numbers will have a digit 3. Plus, there are 10 numbers which will have a digit 3, because everything is the decade of 30, starting with 30 up to 39. Entire 10 numbers will be having 3 in it. So similarly, if you go, then entirely hundreds, if you go, then 100, 200, it's okay. But entire 100 numbers, which is starting from 300 to 399, all of them will have a digit 3 in it. So you will have to not count it. So that's how, if you smartly do this, then you will come to know that 474 is the answer here for this one. Okay, so 17th question, there is no formula, there is no other formula. You just have to count it, but you don't have to count 1, 2, 3 like that. You can be smart about it. You know that when in every 10 numbers, there will be one number containing 3. In every 100 numbers, there will be additional 10 numbers that will contain 3. Okay, so that way you will take it out. And then in case of hundreds, there will be additional 100 numbers that will contain 3. So like this, if you do it, then it is, that is the way to answer it. So okay, question number 19 is very, very interesting. Let us solve it first. Okay, ABC, BCA and CAB are 3 different 3-digit numbers. Okay, they are not same, which means that you know that A is not equal to B is not equal to C, because if any 2-digit numbers would have been same, then that would have been the case. That is not the case. So each of the digits are very different. A digit can be anything from 0 to 9, but here already know that each of the things A, B or C is appearing first as the first digit, which means that it cannot be 0, right? So you will never write a number as 033 or 034. You will just write it as 34, and it will become a 2-digit number. The very fact that it's a 3-digit number means that the first digit is non-zero, right? So you already know that A, B, C, all 3 of them are digits in the range 1 to 9. Okay. Now, what is the question that says ABC, BCA, CAB are 3 different 3-digit numbers whose sum is a 4-digit number with different digits. Okay. So you add all 3 of them. Okay. Then you get a 4-digit number, and that 4-digit number has got each of the digits is different. Now you are asked to guess it. So there is one clue here. If you apply, then you will be able to get the answer very, very easily. So we have used things. So think about it. Think about what we can use. It has to do with the what?
The digits are between 4 to 9.
So A plus B plus C is greater than 9.
A plus B plus C is greater than 9. Yeah, I think you can. That is one very clear conclusion. Definitely. What were you saying? A, B, C are greater than 4. Huh? I'm not sure how. What is each of them are more than 4?
Yeah, because
No, I can't. I can't really. So I have given a clue here: place value system and max sum of 3 digits. Max sum of 3 digits can only be 27. It cannot be more than that. Okay, and it is the clue of place value system. That if you do it, then you will get it. So think about it. Think about it. Anyone getting the clue with respect to how we can do it? See, they have said that they are summing it. They are summing the numbers ABC plus BCA plus CAB. So they are summing it and they are getting a 4-digit number. Whose they are also giving a clue. Each of the digits is different. This is the crux of the problem. If you get this, then you can get the problem. You can solve it. What is the place value system means? In a 3-digit number, what is the place value of the first digit, leftmost digit?
Sir, left, then 100.
So 100.
Correct. And then middle will be
10.
10.
10. And the last one to the right will be
1.
1. Right? Okay. So that is the thing. So, okay. So what I will do is, I will stop sharing and go to the.
So that means 100A plus 100B plus 100C plus 10A plus 10B plus 10C plus A plus B plus C
Correct.
is equal to the 4-digit number.
Correct. Absolutely right, Sai Pranav. You are absolutely right.
So
what does that mean?
101A plus 111A plus 111B plus 111C.
Correct.
So
Correct. Absolutely right. So let us take it. And now once you get it, so
that means number has to be greater than 3333.
equal to 100A plus 10B plus C. Then B, what is that? BCA, right? Next, what did he give?
So is equal.
ABC, BCA, and CAB. So BCA is equal to. So everyone just follow what plus 10C plus A and CAB is equal to 100C plus 10A plus B. So when you add all of these three together, what will you get? 111A plus 111B plus 111C. Correct? Add all of them, right? This is equal to 111 times A plus B
A plus B plus C.
right?
Yes, sir.
Is a 4-digit number with different digits, right? Correct.
Yes, sir.
Now, just so how many values can ABC be? Minimum value of ABC is what? We already know that it can be between 1 and 9. So minimum value of ABC is 1 plus 2 plus 3 is 6. And they are different. ABC are different, you are told. So one of them can be 1, another can be 2, and another can be 3. These are the least possible.
So, but 2 of them can be the same, right? So it can be A is 1, B is 1, and C is 2.
No. They are told, right? We are told already that they are different.
So the 3-digit numbers are different.
3-digit numbers are different. Okay, they have not specified it, but you have to take it that way only. You have to take it that they are different. Each one of them. I think they have not specified it good enough, but they have to. Yeah, you are right that if A and B are same, then it is possible that ABC, BCA, and CAB can be different. But I think that's a limitation of the question paper. I think this is where it is. You assume that all 3 of them are different. Okay, all 3 of them are different. Now, minimum value is 6 and maximum value is what? 6 and maximum value is
27.
7 plus 8 plus 9. They are different, right? So it can't be. So maximum value is 24. So somewhere between 6 and 24. Now, first you start basically. 111 into 6. You will not get a 4-digit number.
Sir, it should be more than 10.
More than 9 it has to be. Okay? More than 9. Because 111 into 9 also is 999. Okay?
Yeah, so sir, into 10 also we'll get the similar digits like 1 and 0.
So that is the clue. So now you see it's a 4-digit number with different digits. So now let me just bring up the calculator. It is I will have
It
to
can't be 11 also.
it can't be 11. There are only 2 possibilities, and out of that, then you will be able to eliminate 1. So let me stop sharing. Now that you have got this, so let me share the screen only. Share screen, desktop. Fine, here and calculator. Let me get it. Calculator. So if you just multiply, okay, you will find that 111 is such a peculiar number that into 10, you get 3 of the digits are same. Obviously, it can't be this, right? So 111 into 11. So what does that mean? We just add 1. Again, you get 2. It is 2 digits. I mean, there are 4 digits, but there are 2 pairs of digits repeated. So this can't be that. Add it. It is again 1332. Again, 2 digits are different. I mean, same. It can't be that. 1443. It can't be this. 1554. It can't be this. 1665. Can't be this. Same thing will continue. It can't be this number. It can't be this number also. It can't be this number also because 9 is repeated. Now, this is a possibility. 2109 is a possibility. Correct?
Yes.
Right? What was this sum of the ABC was how much? Divided by 111 will see it. So it 19 is a possibility. Okay. Now, after that, you start again into 111. Now plus 111. Again, there are 3 digits are same. It can't be thing. So this was for 20. This is for 21. Not possible because 3 is repeated.
No, sir, it won't be because plus 1 to each.
Yeah, everything will keep having 2 digits will be same. So we said that 2553. This is also not possible. We said that it can, the sum of 3 digits can be between 6 and 24 if 3 different digits. And we find that 19 is the sum which is possible here. That's way you can get it. In fact, you are not asked to, you are just asked to tell what is the 4-digit result. So you know that it is 111 into 19, 2109. That is what is the result. Okay, and you are only asked that. You are not asked to tell what is ABC. Because with this much information, you cannot figure out what is ABC. There are many possibilities. Okay, because 3 digits have to sum up to 19. So how can you do it? Yeah, you can have one of them as 9 and other 2 of them being 6 and 4 or 7 and 3 or 8 and 2 or 1 and 9 you cannot have it because the 2 digits will be repeated. But other possibilities are there. 2, 8, 9, 3, 7, 9 and 4, 6, 9. Right? There is also a possibility that you can have 5, 8, 6, something like that. So there are many possibilities. But anyway, you are not asked to do that. You are only asked to tell what is the 4-digit result. And that you can get it because you know that is the big, see the moment you get this 111 times ABC, right? You get a very big clue because 111 is such a number, 11, 111, etc. Because most of the time when you multiply it by any number, you will get a very repeated digits. Okay, sometimes all digits will be repeated, at least few digits. There are very rare cases in which no digit is repeated. And that you can just find out. Okay. All right. Question number 18, I think, is simple. I think all of you should get it. Just read it and think about it. Kaveri constructed a square on a grid of unit squares. Okay, unit squares means there are smaller squares of 1 unit size, and then you can have. So that's why I've said that imagine like a chessboard.
Like a graph paper.
Yeah, graph paper or something like that. But but whatever is the larger square has to consist of smaller square. So I think because all of you are playing chess also, so you know, chessboard is a very good example. Only thing is that chessboard is very specific size, 8 by 8. Okay, now instead what she is saying is that imagine an extended chessboard. So that's why, I mean, it can be of any square. So don't think about it as 8. It can be any number. It can be 7 or 9, 11, 10, 12. It can be anything. Now she's saying that she colored all the 21 unit squares placed along the diagonal of the constructed square. Okay. And so which means that all the total number of squares along the diagonal is 21. That's what it means, right? Because no square on the diagonal she left. She said that she colored all the 21 unit squares along the diagonal. Okay, so what will be the size of that square? What will be the side? First you have to get that, then you have to answer the second question.
Sir, I know how we can solve this 18-1. Sir.
Yeah. Tell.
Sir, so first we take 21 as a diagonal. Then we use Pythagoras' theorem to find the other two sides. If we take it as a right angle triangle, then from that we can get one side of the square.
Yeah,
then that times 4 will give us all sides of the square.
But what is the length of the diagonal?
So that would be.
It is not 21.
Yes, sir.
See, can you see here? There is diagonals. She's saying diagonals. There are two diagonals, right? So the sum of the squares along the two diagonals is 21.
So that means 11 is a diagonal.
Because see, if you see any even sided square, it will have a diagonal. The sum of the diagonals will be even again, because 8 plus 8. In chess there are two diagonals, 8 squares each on the diagonal. 8 plus 8 is 16. Okay.
Yes, sir.
So the 21 will come only if it is an odd shape, and it will be, actually you can just make it out. So if it is 11 squares are there, then will it be 11? Yes, because see, in chess what happens is the two diagonals are of different colors. Okay, because they are not intersecting each other directly. There is no square which is falling on both the diagonals. But when you make an odd numbered square, then one square at the center will fall on both the diagonals, and that is how you get, instead of 22 you will get 21. Otherwise 11 squared, you would have got 11 plus 11, 22. But it being an odd number, one square will be there on both the diagonals, which is not the case in an even sided thing. So 11 is the unit of the sides. 11 is the side. Now that you know the 11 is the side, what is the total number of unit squares along the boundary of the constructed square? Boundary means you know now. It is like in chess, it is like A rank. No, what is that? A file and H file and first rank and 8th rank. Okay, that is what is the boundary, right? All the squares along the periphery. Okay, so how many do you get it? If it is an 8 squares, I mean chessboard is there 8 by 8. How many squares are forming the boundary or edge of the chessboard?
I think I figured out how to do this. So I think it would be 4 times square root of 11 square by 2.
Oh, you are making it too complicated. You are just making it too complicated. See, if the side is 8, okay, if a side is 8, you will just count all of them, 8 plus 8 plus 8 plus 8, all the 4 sides. But then each square will be counted twice, because it will be part of the row also and the column also. So 8 into 4 minus 4, 32 minus 4, 28 is the number of squares in a chessboard, because it is a square of 8 by 8. If it is 9 by 9, how much it will be? Think about it. How much will be the total number of squares along the periphery, along the edge?
To find one edge, it would be square root of 11 to the power 2 by 2, right?
No, you are getting complicated. See, the formula is very simple. Each of the, it's a square, right? Correct.
It's 11 square by 2.
No, don't
square
think like
root
that. Sai
The
Pranav, don't think like that.
perimeter
11
minus
into 4 minus 4. N
Yeah.
into 4 minus 4. Whatever is the number of sides. If it is 8, N is 8. 8 into 4 minus 4. Because 4 squares at the corners get counted twice. That is why you have to reduce it. Otherwise, you will simply say 8 into 4, 32. But it is not 32 because some squares get counted twice at the corners. So 8 into 4 minus 4, 9 into 4 minus 4, 10 into 4 minus 4. Similarly, in case of 11, it will be 11 into 4 minus 4. So how much is it? 40. So 40 is the answer. Just think about it. Everyone got this? Just imagine. I mean, I have not drawn this because I thought it is very easy to imagine.
No, so I'm saying to find the edge from the diagonal. So like if the diagonal is 11, we
You
get the square of that. Then by Pythagoras theorem, we can get an edge.
No, but wait. I think you are going off track because we are not asked to length of the thing. You are asked the total number of unit squares. Okay, so it doesn't really matter what is the length. How many unit squares form the total periphery? That is what is asked. Right, Pranav? So here we should not just go along that hypotenuse and right angle. You don't have to do it because how many squares form the thing? That the number of squares along the diagonal is same as the number of squares along the side in a chessboard, right? Similarly, in any square consisting of unit squares, it is same. It is not different. 8 along right side, 8 along top, and 8 along the diagonal also, right? Similarly,
okay, so now I understood.
so it is not asking you the length of the diagonal or the length of the side. It is just asking you how many unit squares. So, okay, cool. All right. So that is that. So 17, 18, 19. Okay. Last one is 20th, I think. 20th, I think, is what is that? Laurel and Hardy live in the same floor of a 40-story building. Okay. Ground floor and the basement are used for parking. So each of the 40 floors, so they are not the floors used for things. So in each of the 40 floors, there are exactly 10 living apartments, which means that it is starting with first floor, right? Because ground floor and basement are for parking, garden, etc. And there are 10 apartments in each of the 40 floors. So it starts with floor 1, first floor, goes up to floor 40. They are assigned 10 consecutive whole numbers as follows. First floor, 1 to 10. Second floor, 11 to 20. So like this, it will go up to 9th floor. How much it will be? 81 to 90. And 10th floor, it will be 91 to 100. Okay. Similarly, like this, all of them are 11th floor, 12th floor, all the way it is like this. Okay. Now, the sum of Laurel's floor number and Hardy's apartment number is 239. So Hardy's apartment number is dash. So again, it has got to do with, see, this is a regularly
So
increasing.
that would mean Hardy's apartment number plus Hardy's floor number will be 239 because Laurel and Hardy's are on the same floor, live on the same floor.
Correct. But see, Hardy's apartment number is already containing the floor number, right? So you don't have to count it separately. You just have to count Laurel's floor number and Hardy's apartment number. Okay, is 239. So first of all, so you see that you will be able to find that Laurel is on the same floor and Hardy's apartment. So you know that you just start counting. Suppose, just imagine, because it is 239, right? So you just imagine Laurel is on the 20th floor, suppose. Okay. So what will be the apartment numbers on the 20th floor? Just imagine 40th floor, they have given 391 to 400. 30th floor will be 291 to 300. 20th floor will be how much? Apartment numbers of 20th floor, how will they be numbered?
199 to
191 to 200.
Yeah.
191 to 200. Now, Laurel's floor number is 20 and Hardy's apartment number minimum is 191, maximum is 200. What is the value you will get? Maximum value you will get 200 plus 20 is 220. Correct? Hardy's apartment number maximum can be 200 if they were on the 20th floor. It is not possible on the 20th floor because the maximum value you will get is below 239. Okay, what if they are in the 21st floor? Then Hardy's apartment number can go up to 210 plus 21 is still 231. Still it is not possible. So they cannot be living on the 21st floor also. Okay. They can be living on the 22nd floor because 22nd floor, the apartment numbers will go from 211 up to 220. And 220 plus 22 will be how much? 220 plus 22 will be how much?
Sir, I found the answer.
242. And after so you just know that they are somewhere in the 22nd floor. Okay, so you just find it. So 22nd floor, so Laurel's floor number is 22nd. So 239 minus 22, how much is it? 217. So Hardy's apartment number is 217. It cannot be anything more than. See, the moment you go to 23rd floor, what is the minimum apartment value? It will be 221. 221 to 230 will be the apartment numbers, and 221 plus 23 will be how much? 244. So they cannot be on the 24th floor. They cannot be on the, they cannot be on the 23rd floor. They cannot be on the 21st floor also. So they can only be in the 22nd floor. In fact, so the method that I have used is regularly increasing sequence. So there is a meaning for this in mathematics. What is regularly increasing means some number which only increases. It can never decrease. Okay, some sequence of numbers. Okay, there may not be exactly a same simple pattern, but it is always increasing. Okay, so you find that the sum, if you do it, it is always increasing. It is never decreasing. So because of this, you are able to zero in that it is on the 22nd floor. And once you know the 22nd floor, then you just get it. Right? So this way to solve it. So any time when you see any clue like this, I mean, the mathematical way to solve it, think of it. Acha. Oh, this sequence, because they are talking about asking the sum. The sum, you just do it some few examples in your mind, you will know that it is a regularly increasing sequence. It is never decreasing. Once you know that, then you just find the small range which is around this, that you get it. So you just do it. So that's why I jumped directly to 20th floor. I did not try anything because I know that 20th floor, it can only go up to 200 plus 20, 220. Right? So we are very close, 220 and 239. We are very close. Then you just find out after that. 21st floor, we could still not do it. So 21st floor, it was going to 210 plus 21 up to 231 it was going. So we are just going from after that, right? So that is it. So I think we have solved the entire paper. Okay, there are numbers. Some of them I have not gone with because I find them too boring, but it is easily solvable. Like number 14 and 15 are very easily doable, but there is no formula there. You just have to try out different things and you get it. That's why I did not go through it. And you know that there are only digits. So there are only possibilities are 0 to 9. So you just try out all the things, you get the answer. So that's why I did not do 14 and 15. But I think rest everything we have solved it. So good. Thanks for your patience going through this. But I hope you did this give a question paper going through all of them one by one. Did you get different types of things and what logic we can apply? I hope it was helpful.
Yes, sir.
Right, and most of the time you have to get clues from the question itself. There are some constraints in the question, and that is what you have to use it. Like here, 3 different digits. Sum is a 4-digit number with different digits. This should give you the clue, because then you know that, oh, there are only few possibilities that you have to try. Right, most of the questions related to digits, you can get it if you know that the sum of the digits can be only this much. 2 digits can be only maximum 18. 3 digits can only be 27. Carry forward can only be between 0 and 1 or 0, 1 and 2, like this. So that is that. So